Anybody? All right. Preview of coming attractions. It's a trailer. First of all, I'd like to just thank the previous speaker. You're going to hear, if you don't believe what he just said, I think I'll be able to convince you what he said is correct. Okay? Because we kind of dovetail here. I just want to indicate that there's an additional author on this paper, and that's Nick Azzolina, who somehow, well, after we submitted the abstract, he wound up doing a whole lot more work, and then a lot of his work is in this. Okay, so what controls methane in potable groundwater Appalachian Basin? What I'll be presenting are the results of the very, very large Chesapeake Energy pre-drilling database. We already have submitted 4 papers to various journals, and I'll be talking about the spatial methane distribution and methane proximate to the oil and gas wells today. But we also have paper out on the temporal variability of methane over time in domestic wells. In a nutshell, it varies by an order of magnitude during the year in pretty much all places. So there's a lot of variability. And then also the geochemistry of potable waters, much of what you heard about from the Cabot database just a moment ago. Okay, the Chesapeake database is enormous. It's largely in Bradford County in northeastern Pennsylvania, 11,000 samples there, and these are sampled, these are domestic wells sampled around prospective new wells that were being put in using unconventional methods of horizontal drilling. And then in the western part of Appalachian Basin for the Utica Shale play, 7,000 or 8,000 samples. Basically, within the heart of these areas, Chesapeake sampled statistically the entire population of receptors. So we don't have to deal with worrying about whether the sample selection was statistically representative. For all practical purposes, Chesapeake sampled so much prior to drilling that they capture the entire population. So this gives us an enormous opportunity to look at a very, very large database. Now I'll be talking about methane mostly today. Not the Chesapeake and their consultants sampled according to EPA and regulatory guidelines. The sampling uses the inverted bottle method. There's the EPA method of analysis. During the course of the 10 years they were sampling, the detection limit changed, but for statistical analysis, we assumed that all values below 26 ppb would be considered non-detect, recognizing that, in fact, we often got detects below that. But we wanted to, for statistical analysis, for some of the tests, we had to pick a single non-detection rather than 2. Okay, I'm going to go through this very quickly because I imagine there'll be questions. Look at the colors. Look at the orange and red. I'm from Syracuse, the orange bin, so we color that orange and red, and these are where the highest concentrations of methane occurred prior to drilling of unconventional gas wells. All right, and so you can see there's a large number, about 23% being above the detection limit of 26 ppb. Having said that, we found methane in practically every well if you went down to the lower detection limit. So methane is pretty much ubiquitous in the fractured, clay-rich sediments in the Appalachian Basin. If you go to the western part, we got about 25%. And these percents, given that kind of detection limit, is pretty much what everybody else has been finding. The fact that there's methane that we're finding naturally before we drill our wells, be it Chesapeake or Cabot or anybody else, is not a surprise. The USGS in upstate New York, where there is no drilling for unconventional gas, Paul Hysek and Tia Marie Scott published a very nice paper recently. And these are for about 150 samples collected in southern New York. And you can see just the methane's on the ordinate, and you can see there's a lot of methane. And then right there is where our detection limit was. And you can see there's a lot of methane below that 0.026 part per million. And when I called up Paul and I asked him, he said, we found methane in every well. And this is where there is no unconventional gas. And the previous speaker showed this figure here of the eternal flame in the middle of a waterfall, which is a natural seep of methane. And so there's plenty of natural methane found in Appalachia. All right, so it's no big surprise. Now, why is it there? You heard a lot about why it's there from before, but here's a nice schematic hydrogeologic cross-section. And you can see the upper part is a very active flow system, and these waters are largely calcium bicarbonate type waters, oxygenated waters. And so in that upper, if you have wells in that upper section, you generally have very little methane in them. But then as you get into the deeper flow system, where you get ion exchange happening, you get more sodium bicarbonate type waters, and eventually below it you have the brines of the Appalachian Basin. Now, we've known since 1960 that about 600 feet down throughout the Appalachian Basin, more or less, you come up with literally Appalachian Basin brines, which are probably millions of years old. So at that interface, if you have a well that is approaching that interface, you get the natural diffusion of salinity upwards. And that's why you can see in the valleys, if you have a well there, you can get a lot more chloride in the valleys. All right, so just like the last speaker, the more, if you this is a different kind of classification. We're a little coarser in terms of the water types. But in the upper part is northeast area, again, we're looking at almost 20,000 samples. You can see on the sodium chloride, the sodium bicarbonate waters, look for the orange and the bright colors, and that's where you have most of the methane. In the uplands, you don't. We found the similar sorts of things with this database. Here's just a little snapshot of a piece of the northeast area, and you can see the bright color, the Christmas colors are in the valleys, and that's where the wells are much closer to this saline interface. So, you know, I view this kind of like seawater freshwater interface, you know, where if you put a well that's close to that on the shore, you'll come up and wick up some of that sodium chloride, and it's anoxic. And it's the same thing here in the Appalachian Basin, although these are the original brines. Now, I'm going to move to a little bit of a different topic. Here's a figure that's gotten a lot of press and a lot of interest, and it's generated a lot of interest in additional research as well. It's a figure produced by the Duke Research Group, which purportedly shows that the closer you are to an existing well, oil and gas well, the more methane you'll find in your drinking water. And so this figure has been published and republished and presented and represented numerous times. It's based on about 150 samples. You can see their location, some of in New York, some in Northeast Pennsylvania, and quite a few located, I don't know if I have here it is, quite a few located at Dimock, Pennsylvania, where there was a known gas release because of a variety of reasons. So the question is this true? If you have a domestic water well and it's close to an existing gas well, be it an old one or a new one, would you anticipate to have more methane in your water at all? So again, this is an enormous data set, and so Northeast Pennsylvania, we know where all the pre-existing wells occurred. And so they're in this area where Chesapeake had focused their sampling, and again, I just want to remind you, they sampled the entire population for all practical purposes. So we aren't worrying about statistical, you know, whether we've got enough to represent it. Within this area, there are about 4,000 gas wells that were drilled in oil and gas between 1929 and 2013. We have conventional, vertical wells, and we have unconventional, and it's an enormous data set, so it's kind of hard to see them all, okay? So this is what the prior study showed, and this is what the Chesapeake data set showed, all right? Now, one can argue it's kind of hard to see what's in this bottom part here, so we can log it, and this is what the Chesapeake data set looks like of 20,000 samples, more or less, when it's logged. And were there a relationship, it's a semi-log plot, were there a relationship that as the closer you are to a gas well, the more gas you should expect in your water, drinking water, you'd find a curve in this shape. But I don't see a curve like that. So just visually it tells me there's nothing there. But we applied every kind of statistics we could think of to that data set. Here's just one example. We clustered them, we clumped them, we binned them. This is what Nick Azzolina did. So the percent detection of dissolved methane versus distance to an oil and gas well in meters. We see nothing over here suggesting there's more methane or greater detections closer to an existing gas well. Here's another example, distance of the nearest oil and gas well on the ordinate and the binned methane from below detection all the way to greater than 10. They all look pretty much the same. And we applied a number of statistical techniques, some of which I never heard of, but Nick knew about, and parametric, non-parametric, the test of proportions, the percent detections greater than 1, greater than 5, and greater than 10 are the same, 500, less than 500, 1,000, or 1,500 meters from oil and gas wells, logistic regression, survival analysis, which is an interesting statistical technique, and all sorts of correlation analyses using parametric and non-parametric. And there's no relationship between the amount of methane in drinking water wells proximate to existing oil and gas wells, new ones or old ones. So this raises a very interesting question. There's all this talk now about failed cement, incomplete drilling operations, and that there might be a non-point source problem if, in fact, unconventional gas drilling is brought to places where it has not occurred before, like upstate New York. This data set, at least, suggests that that's not going to be a problem. Now, I'm not saying, and nor would my colleagues say, there are no problems. Obviously, there have been cases of fugitive gas release in Pennsylvania because of failed cement. You can count them on a couple hands out of thousands of wells. And there's obviously other issues related to hydraulic fracking. But the idea that hydraulic fracking is somehow going to, I think, compromise groundwater on a very broad basis, to me makes no sense, at least based on this data set, which is the largest I've ever had to work with here at Syracuse, or when I worked with the USGS prior on some large projects. So let's see, I think that probably, so the conclusions, and I went through this pretty quickly for questions, and I think we're maybe a little bit behind. Anyway, but dissolved methane is ubiquitous in the Appalachian Basin groundwater, but particularly in sodium and chloride-rich waters, as you heard from the last talk. All right, and there's rationale for that. There's reasons for that. These are much older waters, and you're getting reduction going on, and it's producing the necessary conditions for methane. And then the saline waters, you're wicking up that Appalachian Basin brine at the bottom of the freshwater system, which is loaded with methane. All right, so that's why that naturally occurs. And I agree completely with the last speaker. I mean, if you have a calcium bicarbonate type water, and you don't have much methane in it, and suddenly you get all this methane and there's a well nearby, then there's something you look at. But if you have a sodium bicarbonate type water, or a calcium chloride type water, or some mix like that, all right, and you get a bit more methane in, and there's a well nearby, you should not probably worry about it. It's probably natural. In any case, if you have a water well which is not, Alka-Seltzing up methane, and you don't see a violent gas come out, or if you have any well where you suddenly see violent gas coming out, and I've seen cases of this, well, then and there's a well being drilled nearby, that does suggest that there might be a problem. All right, and so with sampling the entire population in Bradford County and the areas around it, the entire population of domestic receptors, I've seen from this data set no evidence there's more methane in drinking water proximate to oil and gas wells. And it's independent of the timing. The old ones or the new ones, you can parse it out any way you want. And so this raises to me the question that people have brought up recently of all this failed cement and such. Is this real or not? It may be in some places. Is this a large-scale non-point source problem that people have to worry about? I don't think so. There are other issues related to hydraulic fracking that we probably do have to worry about, but not this one. Thank you very much.
Any question for Don?
We used exactly the same statistics that the Duke group did, but they used the wrong statistics. They didn't include the non-detects in the statistics that they used, and we used theirs without the non-detects and with the non-detects as well in order to capture it, and there was no difference. No.
Yeah. Does your data set tell you anything about methane oxidation once the methane gets into the shallow aquifer?
Yes, it does. Now, I didn't go through it. Chesapeake did get isotopic analyses for most of the samples they collected. Fred Baldessari just published a paper on the isotopic work, and you can see in some cases the oxidation of it. It's almost all thermogenic. There's hardly any biogenic methane.
Just to clarify, I have to imagine you did this, but with all the entire data set, it seemed that a lot of it was baseline data, yet what you showed with regard to methane versus proximity to a well for those post-drilling data?
No, everything was baseline data in the context that when Chesapeake was putting a well in, they had to sample, they sampled a mile or so around it, sometimes two, to get all pre-drilling data. But within that entire area, there were 7,000 pre-existing wells. All right, so in some sense, and many were pre-existing wells were close to where the new pad was going to be placed. And so in a sense, this captures both. But no, they didn't go back in afterwards and then do it. And so this is all pre-drilling data.
And those pre-existing wells, were they vertical wells or were they?
There's about a third were vertical and the rest were unconventional. Yeah.
Don, did you by any chance apply any spatial statistics to your data, such as variogram analysis, to look at how correlation shifted with distance?
That we didn't, but we sure could. Yeah. Yeah.
So did you look at additional isotopes like carbon and water to understand the processes?
The carbon and water, well, no, the Chesapeake, I just was very fortunate to get access to this data set, but Chesapeake did not look at say, the isotopes of dissolved DIC, okay? They only looked at I wish they had, okay? But they only looked at the isotopes of the gas in the water. That would have been really great, Yeah. It's in review. This one here. It's in review. Oh, the question is this been published yet? Is the data published? Well, the paper is in review right now. ES&T, Environmental Science and Technology. This particular one is that. And there's another paper showing the spatial distribution of the methane submitted to Applied Geochemistry. And we're optimistic that both will be accepted fairly soon.
Great.
Okay.
Thank you.